Are you able to see my slide?
It's coming through.
Yes.
Yes?
Yeah.
All right, cool. So greetings, everyone. Thank you for joining us on the Exchanging Ideas 19 Global 5G Evolution. A big welcome to all the speakers from worldwide to join us and give a fantastic presentation. There will be a Q&A session towards the end with the question and answers of the latest trends and latest updates in the market as well. So let's move on with my presentation titled, How Could Cloud Gaming Benefit from 5G? Now, this is a cheat sheet to gaming audiences to give an experience in terms of the various devices, starting from smartphone, laptop, PC, and what we see on the screen is the audience size, average of age of game users, the genders, and the interest in the gaming, plus the gaming frequency. And it is interesting to see the smartphones has gained a good traction in terms of growth when it comes to the usage of smart gaming. And the other area, interestingly, is the esports, because esports is something is very interestingly growing for the last 2 years. The esports market has boomed in recent years with more and more viewers tuning in to watch their favorite games being played by some of the best games in the world. So by 2024, they are expected to almost of 286 million of esports enthusiasts worldwide, a vast increase from the 197 million in 2019. And there is a huge growth of forecast of viewers in esports by 2024. And currently more than 250 million people are watching esports, and most watched games are on the Twitch platform. And some of the interesting games like Grand Theft Auto, League Legends, Apex Legends, Fortnite. The other area is the PUBG Mobile. PUBG means Players Unknown Battlegrounds. That is quite a trendy, world's most popular esports. In terms of hours watched in 2020 was about 132 million watched hours. Live streaming is also quite an interesting, where the video platform on Twitch is the most popular ways where viewers will watch their favorite game stream, their gaming exploits, and a combined total of 6.51 billion hours were watched on Twitch platform. Even YouTube and Facebook can't come closer to Twitch platform, because YouTube gaming was about 1.3 billion and Facebook was 1.1 billion. Now, this is quite interesting slide when it comes to where new gamers are coming from, and the percentage growth between 2018 and 2020. Surprisingly, the higher percentage of age range is coming between 55 to 64 years old. Even grandparents are very popular in playing games. Saudi Arabia is the highest in terms of the watch games, play games, followed by Taiwan and France as well. The other area is based on the percentage growth of internet users who have played a game in the following genres. Simulation is quite popular because simulation is a game which attempts to copy various activities from real life in the form of the game for various purposes. For example, like training, analysis, predictions, and also entertainments. The famous like the plane simulator is one of the trend. Others like war games, business games, role play simulations also is quite popular. Secondly, most trend is the puzzle platform as well in terms of the jump and run games. The other area is the real-time strategy games where like a StarCraft, Warcraft, Command and Conquer, Fortnite also is quite popular because Fortnite and Animal Crossing is one of the immersive world that is trending nowadays. This is a presentation in terms of the survey between the game consoles, the household gaming, laptops, smartphones, and what are the reasons that most of the users are playing these games. For main reason, for fun, and number two, based for the challenge kind of terms, and the other area is storylines and narratives as well. The other part is quite interesting is that some of the or most of the gamers who have frustrations about gaming have complained that it doesn't run smoothly and it's too expensive to progress and it's too hard to play. So I think don't run smoothly. It's really related to the latency issues, and the speed issues, and that's where I think 5G will also play a bigger role, which can able to solve the gamers' frustrations. This is quite an interesting slide where the percentage of gamers who used social media that use the following services for gaming, information, and content. And the best part of this is that most of this, this is a bit backwards. Is the survey has been done somewhere between 1880 to 2020, and that's the reason YouTube is the top. But if you see the latest statistic for this year, I'm very sure that Twitch is taking in the higher level. And so interestingly, a lot of streamers, there are also a lot of critics. That means a lot of players would love to fill in the comment box and try to critics each other in terms of the gaming experience. There are also passive users as well. So with this in the mind, brands will need to think carefully about how they use different platforms too, right? So each of these group companies, like, they are very much interested to put up their branding in on this social media, and that will be it'll get a good reach out in terms of the advocacy to their circle of friends, and also resulting higher growth of followers. So that is another trend of social digital marketing as well, and also in terms of bringing in powerful ambassadors from the gamers community. Now, this is quite an interesting slide in terms of the cloud gaming providers, where there's a strong demand needed in the B2B market for cloud gaming solutions. And this is a typical example of a telco with the edge application communications and services with the core network and the radio network. And they are having a connection with the subscribers, for example, gamers. They are offering monthly subscription fees or an annual subscription fees in terms of gaming and data subscription. And the gamers will pay those subscription bills based on the bills. And the telco also are integrating with the cloud gaming provider. This is quite a new concept, cloud gaming provider. And some of the favorite like GameStream or NVIDIA, who have built the cloud gaming as a cloud gaming service provider, and they are connected to the game publishers and the developers. There's like thousands to hundreds thousands of developers, right? So they share revenue each other, and that's how the cloud gaming will share some sort of partnership with the telcos. And the telco bundles third-party products and services to provide a complete cloud gaming experience through a dedicated network slice and edge cloud capabilities. So the network slice plays a key role between the telco and the cloud gaming provider as well. So one of the favorite example that I would like to share was StarHub recently launched the GeForce Now, which is available for all Singapore. And StarHub is the first in Southeast Asia and the only operation in Singapore to introduce the GeForce Now cloud gaming service to access all over about 1,000 games from as low as 11.99 Sing dollars and also on a yearly fee of 119 Sing dollars as well. So and this is something that is quite popular trend in Singapore. South Korea also is quite popular in terms of the gaming experience as well. So in terms of the 5G, when it comes to the key technology enabler for cloud gaming, 5G could deliver on the promise of a cloud gaming in terms of three promises. One, cloud gaming will enable a high quality games to be played at home or away from home, where like FWA for those home users, that is quite a trendy in some of the European countries. And if it's a 5G outside of home, then it's virtually in any location where the 5G coverage exists. Second promise is in terms of enhancing the gaming experience. That's very much into the enhanced mobile broadband. And the other area is ultra reliable, low latency communications as well, where, there's less than 50 milliseconds or maybe less than 5 milliseconds 5G is needed. In terms of resolution, it requires about 35 megabits bandwidth. And also in terms of average speed is about 50 megabits per second. The other area was promised is that cloud gaming will enhance the multiplayer experience, because most of these players are in a different countries and hundreds of players from various countries, 30 or 40 countries playing on a real time in the same concurrently. And that's where the edge computing combined with the 5G plays a bigger role to solve all the latency issues, reducing the latencies and the rendering and encoding as well, and bringing the video processing much more closer to the user. And also, as I said earlier, the network slicing also offers a guarantee in terms of the reliability, 99.9999 as well, just to give that the best rich experience as well. And this would be my last slide, that we, Global 5G Evolution, we also provide consulting in terms of addressing what are the dynamics affecting the cloud gaming market, strategies of players adapting to compete on this market, what are the main use cases can be observed in cloud gaming, and also how can 5G technology impact the cloud gaming market, and what is the size of cloud gaming market in terms of volume and values as well. So, so for those who are watching us in this program, please feel free to approach me if you have more clarification, and we would love to actually explain more further the cloud gaming markets, the strategies, the go-to market, the value propositions, the business models, and we will have use cases on reference countries, South Korea, Singapore, and many more European countries, and how they play a big role in the cloud gaming as well. So that's all my presentation. Please click global5gevolution.com for further details. Thank you so much. And I would like to pass on to the next speaker. I would like to pass on to Christian Wagner from Munich, Germany, to present on 5G as a new opportunity for city carrier.
So just share my presentation. Can you see my presentation now?
Yes.
Are you able to put in a full slide?
Okay, yeah. Here we are. Okay, so yeah, my name is Christian Wagner from Bayerische Funknetz GmbH, BAYFU. We are mainly active in Germany or Europe for 5G use cases. We're working on different 5G use cases for industry, like automotive industry, like paper industry, logistics, as well as there are a lot of research projects up and running in Germany. I think around 50 or 60 5G research projects from different universities, high schools, institutes, and which was coming up the last couple months what we saw is that there's a growing interest in 5G from the city carrier. So this is a new branch. What we saw, that the city carriers wants to deal and they want to offer products with 5G products. I think this is a very good solution, 5G, for them, because they are now offering fiber, they are now offering Wi-Fi, they're offering the TV, and as a supplement, 5G is a very valid opportunity. So in Germany, we have the situation that we're working on two frequencies spectrums. So we have the 3.7 gigahertz, which is the in LTE band 43, and in 5G the band N58, and we have the 26 gigahertz. The 3.7 gigahertz only can be applied for private campus solutions. So the use of the frequency spectrum is limited on the campus area. The 26 is a little bit different. The 26 can be used in private campus solutions, but as well in regions like city area of cities, and that gives us the opportunity for different use cases, and which is very interesting as well for the city carriers. Coming to the 3.7 gigahertz, here we have private campus solutions which can be used in industry or as well in business parks. And the business parks are very interesting because nowadays we hear in our talks to the customers or to potential customers that they're often afraid to run an own 5G network. And it's an invest, which is not very less, but and they want to share these. So the idea is we have a business park with X customers, and they all share one common 5G network, a private common 5G network, where we have different possibilities. We can offer it for WLAN so Wi-Fi backhaul. We can offer it for CCTVs, security things, secure data communication. And the beauty of 5G is that with the slicing approach, everyone has its own private network for himself, but it's one physical network. And this is something where the city carriers can step into and can step to and be a service provider, a 5G service provider in this area. 26 gigahertz, this spectrum is something which is perfect for the city carriers, because on areas where they have problems to put fiber to the home or to the different buildings, they can do fixed wireless access with that. This is something what we saw is now very popular in UK. It's very popular in US. We see some activities in Germany, which are the first activities, but it's also we saw some fixed wireless access solutions as well in Czech Republic, for example. And you can use this for different areas. You can use it for your smart city surveillance or for the Wi-Fi backhauling as well. So this is something what we see is very interesting for the city carriers. Coming to a topic, how would this be connected? So we have these campus networks for small, medium enterprises for digitalization of processes with the slicing, what I told you before. And we also have the possibility to have these on one core, which is a cloud core, which is a cloud served core at the city carrier. And with the UPF, so the user plane function in 5G, you can directly route the datas, so the user datas, to your own company network. The same is with 26 gigahertz. You can have your 26 gigahertz with fixed wireless access. You can use it directly to
Christian, we're having a trouble. We can't able to hear you well.
Okay.
Is it to do with your mic or something? Most of us having a trouble to hear your voice.
Okay, so I will change to different.
Now it's working well. Yeah, now it's quite good. Now it's quite okay.
Is it now better?
Now better.
Okay, perfect. So the campus networks are in the area of 3.7 to 3.8 gigahertz, and you can combine it with 26 gigahertz. This is what we see is very good for the city carriers, because they only need one core. They only need one 5 core, which is in their operating center, and they can combine the fixed wireless access appliances as well as the services for 5G for the industry. Coming to that, coming a little bit to the households, there are different opportunities or architectures the city carriers can provide to their customers, to the end customer. They can do their normal fixed network, and they have a normal router, Wi-Fi router, and they also can combine this with a 5G technology. This is good for symmetric down and uploads. This is good for the failovers, or a second backup system, a backup network. Then they have these mobile hybrid access networks, what we see. So you're going in with 5G as well with Wi-Fi, and you can combine these with, which is called in 3GPP, the spectrum, it's non-3GPP access. And the third thing is the hybrid access over a common backhaul. So this means you have one backhaul, so one line to the building, and then you can combine here femto cells, so 5G cells, small cells, with the router over one line. So this is something what we see today as the architecture which we are discussing with city carriers today. So at the end, I want to say city carriers are now very active on the 5G market. It's an interesting topic for them. It's an interesting topic for them as a product on top of their fiber, of their Wi-Fi, and of their TV products which they are offering today. That's it from my side. So I hand over to Kanish.
Awesome. Thank you, Christian. That was a brilliant presentation. I appreciate that. Moving on to the next speaker, let me introduce Dr. Marcin Rajanski from Poznań, Poland, to present on ORAN, RAN Intelligent Controller, and X apps.
Okay, thanks. Can you see all?
Awesome.
Okay, good. So thanks for the introduction and for having me here. Welcome everybody. My name is Marcin Rajanski, the CEO and co-founder of Remedolabs, a spin-off of the Poznań University of Technology in Poland, and we are a research consulting company focusing on wireless communications, Open RAN, 5G and beyond. And my talk today is on ORAN RIC, or RAN Intelligent Controller, and speaking also about X apps. And a few words about what we are going to speak about is a very short introduction to ORAN, because it was sort of part of the other speeches in the previous panels as well. And then I'm going to focus on the RAN Intelligent Controller, and then following that with X apps, and also about R apps. I'm going to see and show the differences between them. And then we'll summarize the things with a discussion point, hopefully for the end and towards the Q&A session, where I'd like to take into discussion the way moving forward with this virtualized networks and Open RAN and XApp market. So a very short introduction to ORAN, where as probably we all in this room Now going towards the Orange from the traditional part where there is a black box without possibility to get into specifics and aspects related to interfaces and management of that network, towards opening the interfaces, breaking up the base station into several pieces and having an open interfaces, and mostly the orange part, that is the thing we are going to discuss here in a little bit more detail, that is RIC or Run Intelligent Controller. This is where the intelligence sits. This is where we abstract out that element so that a third-party solutions could be enabled in general. If it happens or not, time will tell, but the idea is that we go towards that direction. Now, without getting into the details, just pointing several aspects related to the different elements that the Oran architecture is brought with. Starting from the bottom, we have the cloud computing platform, and then on top of that, we put the 3GPP, let's say, base station split into several pieces with remote unit hosting the lower layer, physical layer. Then we have ODU of Oran distributed unit, centralized units with the other protocols in the protocol stack in the 5G area. And then we have the two elements we are speaking today about, basically the near real-time RIC and non-real-time RIC. So the RIC is also split into two levels. The near real-time RIC sitting in the RAN domain, being the logical domain to enable near real-time control and operation, and hosting and serving as a platform to XApps, that are the applications designed to run on this, and that's basically the different algorithms. We'll see those in a second. Then we have non-real-time RIC, so going onto SMO or service and management orchestration. So the management plane, this is where the other RIC in terms of how it manages the overall network sits. That's another logical entity, but in the management plane. And it also is sort of a platform for the AirApp operation. AirApp is another application, third-party application, or of course it could be developed together with the non-real-time RIC, but the idea is that it could be enabled to be provided by third party. And that's more of a machine learning capabilities and overall network management. We'll get into that in a second. Now, if we compose all of those in an architecture, and again, not going into the details, but pointing certain interfaces that are important in that whole setup, is the E2 interface between the near real-time RIC and the blue part, so CU and DU, centralized unit and distributed unit, where in the RAN domain, we could, via the XApps, so the radio resource management and self-organizing network algorithms, could control the RAN operation over a standardized interfaces by the Oran Alliance, and getting the data collection feedback from the network towards the cloud native near real-time RIC. Then we have the A1 interface, again, standardized by Oran Alliance, where from the management plane to the RAN domain, we could control that via policies, additional enrichment information, and machine learning capabilities. And then the final one, which is O1 interface, that is a management interface to all the elements, including the near real-time RIC, based on which we could reconfigure those if there is a, let's say, a longer-term adaptation of based on the measurements and performance. Now, the Oran Alliance specifies certain use cases, and most of them relate directly to the RIC operation and the XApps, like traffic steering, quality of experience optimization, massive MIMO optimization, and they are split into several, or in that case, two phases. Phase one, more immediate needs, and then phase two, that will be taken later on when the first one are handled. So more of a prioritization based on the operator's demands and the requirements from the market. But all of them pretty much relate to the RIC operation and how we could organize the management of the network and what types of parameters are needed, what types of policies are needed, and so on and so forth. Now there is another document worth looking at if you're interested into the Open RAN area. That's Open RAN technical priority document specified directly by the operators, or 5 of them: Deutsche Telekom, Orange, Telefonica, TIM, and Vodafone. And in that case, those operators specify the particular scenarios and other, let's say, elements of the ORAN architecture and ORAN, let's say, entities and aspects that are being prioritized in terms of how the developments in the standard and in the deployments should be organized. And one of those are the RIC use cases. When, if you take a look on those, they are pretty much one-to-one mapped to what we saw in the ORAN Alliance specified use cases. So this is where we put, or the operators put the priorities on those. And as you might see, the traffic steering, quality of experience optimization, they have priority level 0, basically serving as a mandatory operations here. Now getting to the RAN intelligent controller, a little bit details, but still, due to the short time, not getting much into the details. But basically, a RIC is defined to abstract out some of the functionalities that could be then placed as a plug-and-play manner, hopefully in the future. So as an applications called XApps. And those are mobility management and mission control, interference management, mobility load balancing, and things like that, that could then enforce direct actions or policies towards the actual RAN elements. And if you take a look on those, there are RApps sitting in the non-real-time RIC and XApps sitting in the near real-time RIC, where the non-real-time RIC is basically a configuration management and providing the higher layer procedure optimizations, lower adaptation rate, and machine learning models to the near real-time RIC, which is a software platform to enable XApps to work with the RAN, with the different network intelligence, resource assurance, resource control use cases to be then basically able to control the E2 nodes. And the E2 nodes, due to being connected over E2 interface, are basically the ODU and OCU, so centralized unit and distributed unit. Speaking of the interfaces, the A1 is intent-based interface and is responsible to get the policy feedback up to the management plane and getting the policy enrichment information down to the near real-time RIC. O1 is responsible for or logical interface to get the data collection and control over a slower adaptation loop, and getting some kind of additional information. And then E2 interface is a closed loop with the RAN, within the RAN domain, to get the actual control and policy towards RAN and get the feedback from the RAN operations. Now, speaking of the control loops we mentioned already, on top of that, we have non-real-time latency with slower adaptation loop. Speaking of those, is like seconds or minutes or hours. This is typically the management plane, how it's working, with getting the analytics, with getting AI, ML model training, getting, I don't know, trends in the days or in different places of the network, and getting the policy type of management down to the near real-time RIC with near real-time latency, so below 1 second and above 10 milliseconds. This is where the typical higher layer algorithms in the RAN domain work, like mobility management, quality of service management, interference management, connection management, basically. What is important here is that because those could be developed in general by different companies, there is a need for some kind of XApp management functionality, including the conflict mitigation one, so that where the two different XApps would like to change the same parameter, there need to be some kind of mechanism, and that's within the framework of near real-time RIC. And then finally, of course, we need the real-time latency algorithms as well. This is where the typical resource management, the scheduling based on 1 millisecond TTI or shorter in the 5G domain, is working, and this is embedded in the E2 node, so distributed unit that is not exposed and abstracted out from the actual management domain. So this is still there. What could be done with the near real-time rig is to control the scheduler with a, let's say, slower adaptation, and basically with the use of policies rather than the actual needs. So the actual TTI allocation is still based on the internal entity within the distributed unit. And then final point, the XApp thing. So we have XApps already mentioned, applications designed to run in the RAN domain. So on top of near real-time rig, together or in addition to the near real-time rig framework. They could be provided by third party, but of course could be also provided by the near real-time rig developers or providers or vendors. And the most important point is that they are independent of near real-time rig. They are sort of microservice based with the open API defined by the Oran Alliance, so that they could be in a standardized way be incorporated in the near real-time rig framework. And then there is an RApp. That is the difference between them. It's basically because it's running on the non-real-time rig. They are still also in third-party applications, but they are more of different character that are run in management plane, and they are more of providing, or at the output providing, policy-based guidance, perform data analytics, are more of a slower adaptation with the use of machine learning training, and they could also accept of just sending policies over A1, could be recommending reconfiguration towards the actual base station elements over O1 interface. Now the final point is how this all works without getting much into the details. The important point is that we could actually reach the actual function within the E2 node, the functions 1 to n here, where they could be controlled with the use of XApp. So there could be, I don't know, connection management directly being managed by a particular XApp. There is a need of additional element in the E2 node. That's why it's E2, and that's why we have O in front of CU and DU, because that base station developed within the 3GPP world need to be equipped with the E2 agents that need to basically be able to reply and provide the information over E2 interface. There is a database holding the data for and from the XApps, so that we have a state, or the actual state of a network in that same part. Important point is here also, if the E2 is broken or near real-time rig is broken, the E2 nodes and the base stations still need to be functioning except of those. So in that way, the XApps are providing, or are aiming to provide, a little bit more with a better performance algorithms, getting a little bit more information from the overall network, while the basic functionality of the base station needs to be still in the E2 node. So it's not like we put a traffic steering management or mobility management only towards the near real-time rig, and then it still needs to be there in some basic form. And then the final point, also without getting into the details, just showing how this is basically operating in terms of a framework, in terms of defined procedures, where the actual XApp is sending a particular request to the config mitigation, which is then basically within the framework of near real-time rig, and then it basically decides whether to allow it to go to the actual E2 node to give that command. Then it goes to the E2 termination point, so it's not like the XApp is directly controlling the functionality in the E2 node. It needs to go over the near real-time rig framework. And then, of course, the E2 node could have a failure, meaning that it's not basically doing the particular action that the XApp is requesting it. So still needs to have some basic functionality there if it fails. So basically, that could be sort of a how we control the run over the XApps that are third-party applications, but that needs to be within the near real-time rig frame. So to summarize that, rig provides control functionality to enable increased efficiency, optimize network performance. Non-real-time rig acts as a configuration layer and provides that through a one interface towards near real-time rig. RAP is something that is actually sitting on non-real-time rig inside the management plane to provide those guidance and learning mechanisms. And then when we go down to the near real-time rig, it's basically a software platform for XApps for run management and optimization. And XApp are actual radio resource management or SON functions sitting in the run domain that could be delivered by the third parties. And the final point and a question actually for the discussion at the end of the session is, will we actually think that there will be XApp stores like there are app stores for the smartphones, or that could be actually part of, I don't know, agreements between companies for the companies that are working on XApps that are part of the rigs, and they will be, let's say, closed within the rig vendors, or we will have sort of a platforms where different companies could provide algorithms, and then the operators would be able to choose between the different XApps in sort of a common platforms for the opening that market as well. So with that, I'd like to conclude the session and give it back to the organizer.
Excellent. Thank you, Dr. Marcin. I appreciate that. Moving on to the next speaker, I would like to introduce Dr. Charles Turiakyenda from London, UK, to give a talk on the Open RAN.
Okay, thank you. I have a feeling that Marcin has covered most of the things I was going to say, but I'll share my slides and quickly talk through a few points. Please let me know once you can see my screen. Can you see my screen?
Yes. Are you able to enlarge to a full?
Yes, I've moved it to full screen. Is that better? Yes.
I can't see it in full screen mode. If
Yeah, it's not on full screen yet.
Okay, let me press the button and try to get into full screen. Okay. Is that better? Excellent. Okay, so as an introduction, my name is Charles Turiakyenda, and I'm a lead technologist at Digital Catapult in the UK. As some of you may know, Digital Catapult is one of the government's initiative at promoting the early adoption of digital technologies within the UK. And in this space, Digital Catapult works on several technologies like artificial intelligence, distributed ledger technologies, feature networks, IoT. And in my case, I'm mainly going to be talking about Open RAN within the context of feature networks technologies. As I said, some of this has already been, so I'm going to begin talking about an Open RAN system and what it is as a summary, and then I will talk a little bit about our activities in this Open RAN space. So as mentioned before, Open RAN is essentially the disaggregation of the traditional RAN radio access network into individual components so that you could have diversification within the RAN, so that one or two vendors or even more vendors could develop one or more of these components. The split of the different RAN functions are as follows. So you've got, starting from the radio unit going backwards towards the core network, you've got the radio unit, the RU, and this hosts physical layer lower functions, and these include things like FFTs, analog beamforming, etc. And connected to that is the distributed unit, and this one holds the classic radio link control, medium access control, and higher layer functions, higher layer physical layer, high layer functions. In between them, you've got a front haul interface, and this front haul interface is a 7-2 split as per ORAN, and there are variations within this. There's 7-2 Cat A and 7-2 Cat B. You won't talk about those details right now. The key thing is that there is a split between functions at the physical layer with higher phi and lower phi. Higher phi being hosted in the same environment as the radio link control MAC layers. From the distributed unit, we have another collection of functions, which is the centralized unit. And this centralized unit is actually decoupled into two units. You've got the centralized unit control plane, which is the CUCP, and you've got the centralized unit user plane. From the distributed unit to the centralized unit, you've got a new F1 interface, and I have a slide to show what these interfaces are in terms of protocol splits. You also have an interface between the CUCP and the CUP, which is the E1 interface. Now, the CUCP essentially is holding control plane functions, things like RRC and the PDCP control, while the CU user plane has got the SDAP and PDCP, the user plane part of it. There's also a new interface which Martin has been talking about in the last presentation, which is to the Run Intelligent Controller. And I agree with Martin's previous presentation that this is where I think most of the innovation is going to be. So you've got the real-time rig, and that has got an E2 interface between the centralized unit as well as the distributed unit below. From the current implementations, we have seen most of the interface, the latest versions of the Run Intelligent Controller. It's only connecting between the centralized unit and the Run Intelligent Controller. We haven't yet observed any implementation that actually extracts from the DU at the moment. This Run Intelligent Controller, in theory, should provide an A1 interface to other applications for orchestration and automation. And there are several things you could see here. Like, for example, MANO systems, like management and orchestration systems, run and non-real-time rig, for example, which is for operations that take a little bit longer, for policies, for configuration, etc. It's also provides a space, the rig provides a space for third-party applications that extract radio information, things like layer 2 functions that report things like buffer status reports or received signal strength indicators, etc. I'm not going to go into the detail of the picture on the right, because that just simply decouples what is within the phi high layer and what functions are stored within the phi lower layer. Okay, so this provides a basic general overview of what an Open Run system looks like. To put this in context with some of the work that has already been done with 3GPP, which is the split options, because sometimes when we talk about the F1 interface, the question is, what is the split option associated with that? But for the F1 interface, it's the one between PDCP and RLC, and that will be the split option 2. So we've got lots of different split options, and the front haul is split option 7, and there are variations of that. In theory, you could have each of these blocks having different kinds of splits, but for Open Run, the front haul is split option 7, which is here, which is high phi, between high phi and low phi. And for the F1 interface between the CU and the DU, it's this PDCP RLC, which is split option 2. Some of you may be familiar with other options, for example, the Mark V split with the FAPI that was available in the old small cell forum type of discussions, but that is not currently an open run split supported. Okay, with that general introduction to Open Run and the split options, etc., I will talk. I'll just present one slide to show some of the work that we have done in this Open Run space. So at Digital Catapult, we are involved in this Smart Open Run Network Interoperability Center, Sonic Labs. And within this Sonic Labs, so far we have set up 3 Open Run chains. And these Open Run chains have got a different, varying degrees of complexity. So the first Open Run chain at the very top is the one that is made up of an Accelerant CU and a RIC, and a Fluido and FNet DU. So Fluido provides the layer 1 of the PHY, and FNet is providing the DU, and these are connected to the Benetel radio unit, and this is a CAT-B 7-2 split on the front hall. And these are connected to 1+ node UEs. This whole system is set up in our London labs, and it connects to a 5G SA Druid core, and hence the further connection to the application servers. We have a DBC application server for streaming 360 video, etc., and also connecting to the wider internet. The second chain that we have, the second Open Run system that we have is one that's integrated by Wagner, and it's distributed across 3 geographical locations. So one radio is in London, the other radio is in Brighton, and the other radio is in Ofcom Riverside House, which is another location in London. So for the first center, we've got the Wagner centralized unit and RIC, and the Wagner distributed unit and a Foxconn radio unit connected in London. And these in turn connect over the NG interface to the Druid core. At the Ofcom Riverside House site, we've got the Foxconn radio unit and the Wagner distributed unit, and these connect to the Druid core. Similarly for Brighton, we've got a Wagner distributed unit connected up to the grid core. All the radio units are Foxconn in this setup. The third Open Run chain is one made up of radices, and this is equally distributed over 2 geographical locations. We've got the radices CU and DU at Ofcom, Riverside House in London, and we've got a Wagner. A radices CU and DU in Brighton. Radices system connects up to radices core network, and that provides the data plane connection to the internet and other application services. The plan with this kind of setup in the Sonic Labs is to be able to swap things around. So, for example, to take a radices CU and replace it with a Wagner CU in the Wagner setup, for example, or vice versa, or take a Fluido FNet DU and put it into a system made up of radices, for example. So this is to try and assess the openness of the interfaces that we have just described. So the openness of the front hall interface, the openness of the F1 interface, and the openness of the E1 interfaces as well. In addition to this, we also want to explore the maturity of the RIC platforms that are currently out there. At the moment, we have been working with the Accelerant DRAX, which is their RIC platform, and the Wagner RIC platform. All the RIC applications that we have played with so far are just vanilla applications that don't do much at the moment, and considering it's just still early stages of development, this is what is expected. But what we'd expect is to have a third-party RIC application developer come and plug into the API that's exposed by either an Accelerant DRAX or a Wagner RIC solution. So in summary, this is what we're doing in the Sonic Labs in terms of Open Run and interoperability and swappability of the different different run components. I can provide more details to this if needed. But in the interest of time, I will stop here and thank you and pass it back to Ganesh.
Thank you. Awesome, Dr. Charles. Appreciate that. Let me move on to the next speaker. Let me introduce Dr. Peter Raj from Bangalore, India, to give a talk on the 5G and age convergence is to result in game-changing use cases.
Yeah, so this is Peter from Bangalore. I work for Reliance Jio Platforms Limited. Unfortunately, I could not get some time to prepare the slide, so I will talk for 10 minutes. I think.
Yes.
So I don't talk normally much about 5G because that is not, I do not belong to that division. Instead, I work for cloud computing, especially I'm working on edge computing, IoT edge computing division. So we are all knowing about the various use cases of 5G and various new features that are being produced by 5G here. But I would like to how edge computing comes handy in resolving some of the issues that 5G is facing. That is my title today, because we have developed a couple of products based on that. So with that confidence, with that education, I would like to talk about how edge computing comes to the rescue of some of the limitations of 5G. Okay, so typically we all know some of the interesting use cases of 5G. So we will get enhanced mobile broadband. We will get massive IoT devices accommodation. And another interesting thing is 5G is going to help us to have very, very minimal latency, that is ultra low latency for IoT devices. So if you all know that 5G can accommodate 1 million devices within a single square kilometer of radius. So that is the huge advantage 5G is guaranteeing here, where compared to 4G. So typically, when we have more number of devices in an environment, say a retail store or in a educational campuses or in a stadium. So when we have more number of IoT edge devices or mobile devices or any other devices that are getting connected with internet, that are getting connected through 5G, then there are other issues. Of course, you will have very less latency, but at the same time, fulfilling that low latency is not an easy thing. Okay, so today, when we go through the news item saying that in India, at least some of the wireless service providers, including Jio, has prototyped a couple of devices that are compatible to 5G, and they have shown that it can get 1 Gbps data rate. Okay, so but when we go to a practical environment, practical situation, in a typical environment, it is not that easy to get that 1 Gbps data rate. Okay, so at the other end, we are all excited about edge computing. We have been fiddling with cloud computing for a long time, but slowly and steadily with that projected billions of connected devices, edge computing comes into picture. So in the days to come, we will talk more about edge computing. Okay, so what is the advantage? Today, if you take all our data to faraway cloud environment to be stored, to be processed, to be analyzed, we will lose that real-time connectivity, real-time nature. That means for establishing and ensuring real-time data collection, real-time data storage, real-time data analytics, real-time decision making, real-time action, the future is depending or relying upon edge computing. Okay, so the edge computing devices or IoT devices have the capability to collect all the local data in that environment data quickly, and it will do a lot of processing very quickly, because nowadays not only Apache streaming analytics platform, we have done a small POC on that, and not only the streaming analytics platform that can be deployed on edge devices, but also edge AI. So that is a new domain that is coming up very fast. That means we can deploy ML and DL models on edge devices so that we can do prediction, prescription, and other kinds of analytical activities, automated analytical activities through such kind of AI algorithms that are increasingly deployed in edge devices. As you know, there are several platforms and frameworks, accelerators, libraries. These are all being deployed on edge devices. For example, TensorFlow has a lightweight version. We have deployed TensorFlow lightweight version in a couple of edge devices in order to understand how it is able to do edge-based AI processing. So that's what we have done. Now, edge computing is coming up fast, especially for real-time application development. Edge computing plays a very, very vital role over there. Okay. Now, how edge computing is helping for a 5G to accomplish or to fulfill its vision of providing 1 microsecond latency for IoT devices, IoT edge devices. So typically, these edge environments are edge device clouds. When I say edge device clouds, we have combined multiple edge devices to form a dynamic, temporary, ad hoc cluster or ad hoc cloud of edge devices. So for example, you take a smart home environment, therein you can put several devices, your cell phone, your smartphone, or your refrigerator, or your kitchen utensils, or your consumer electronics, or your Wi-Fi gateway. So many other IoT edge devices are being accommodated or deployed in various homes, at least in the advanced countries. So we can have kind of Kubernetes lightweight version like Kube3 or K3s.org. There are 3 or 4 odd lightweight versions of Kubernetes. That's a containerization, container orchestration platform. These Kubernetes can manage multiple heterogeneous devices together to form a kind of edge device cloud. That's what we are working on. And we hope with the maturity of technologies, with the stability of technologies, we will have not only cloud computing environment, but also we will have edge cloud that are being formed out of edge devices. There are several technologies that are coming up in like microservices architecture. We have containers, Docker containers, we have Kubernetes lightweight version. These combined together to set up or to sustain edge device clouds across multiple environments in your home, in your hospital, in the hotel, or in your manufacturing floor, or in your retail store, or in your warehouse. Wherever we have some mission critical tasks have to be accelerated or automated, then there is a possibility for establishing edge device cloud automatically through such kind of technologies and the participation of multiple edge devices. Today we have resource intensive edge devices. For example, even our cell phone or smartphone has 8 GB memory. We have extensively used multiple Raspberry Pi based edge devices, Arduino board. Then we have NVIDIA products and platforms for creating edge device clouds across multiple locations, and these are getting integrated with one another, also synchronized with the faraway cloud environments. Now, such kind of edge environments help us a last mile connectivity platform for 5G, so that the user can achieve that very low latency communication through the intermediary like edge device cloud environment. Okay, so that is the biggest point that is being contributed by edge device clouds in taking 5G to all, with all the goals that are getting fully guaranteed. So that's what currently we are working. For example, we worked on a product that is called ACM product, edge device based ACM access control system, that is being deployed across our offices in India, in Bangalore, in Mumbai. And here we are working with this. We started with 4G, that now we are moving towards 5G. So when 5G becomes a common mainstream communication standard, communication mechanism, so our edge products will take care of, or will use or leverage this 5G communication to guarantee very, very less latency for all our edge devices that are being deployed in thousands, and in future we will move towards lakhs across all the locations wherein Jio offices are located. So that is the era we are going towards in. Not only that, we created a edge device controller using Raspberry Pi. It is having only 1 GB memory. And now within that, we have accommodated around 50,000 employees' data. So when we stand in front of our office door, we need not share the data to faraway cloud. The cloud is in Mumbai. We are standing in Bangalore. The door will open once our data are matched and used by that HR database system that are in Mumbai. So here, by using edge controller, in nanosecond, the door will open. Even if the network is down, or if the network is very slow between Bangalore and Mumbai, or if the cloud itself down, okay, we can achieve that through edge controller. And we are incorporating face recognition module so that we need not carry any ID card also. We just go there, the door will open. So that's the current work we are working on. And with the combination of 5G and edge computing or edge device cloud, all the promises, all the targets that are being decided for 5G will be completely fulfilled. So that is what I would like to share here. Thank you for the opportunity given to me.
This is awesome. Thank you so much, Dr. Peter Raj. Appreciate your input. So valuable from Jio, Reliance Jio India. Thank you so much.
Thank you.
Let me move on to the next speaker. Let me introduce Paul Govens from Edinburgh, Scotland, to present on the automation in 5G.
Okay, hopefully my screen's come up.
Yes, sir.
Thanks, Ganesh. All right, thanks for that. And this will fit well with the discussions that went previously on RAN intelligent controller and open RAN. I'll talk a little bit about complexity, talk about verticals. We won't spend much time on that, but I will talk about automation through the life cycle, since it's important to deliver like problem-free 5G, which is what we all want, right away from the lab, pre-deployment into the field as we turn up and certify, and then as we assure and optimize. So let me touch on complexity, because this kind of gets to the heart of kind of why do we need automation and more automation. So we've heard about verticals and dealing with wide and a disparate range of applications, often with opposing and competing needs on the same network. Couple that with non-uniformity. We've done studies in the past on 3G and 4G networks, and as 5G networks mature, we'll have more data on those. But we found that, for example, 50% of the data is consumed by 1% of the users. 50% of the data is consumed in less than 1% of area. And there's a huge amount of cell utilization variation goes on at the cell site. Now, as well as that, when we talk about optimization and tuning parameters, if you take just 2 parameters on 100 cells, where each of them has 10 possible values, there are actually 10 to the power 200 different configurations. Now that's an unfathomable number that you really can't manually adjust. And the denser the networks, the more complex these environments are going to be. So that really is behind why automation is needed. And this shows you the kind of various verticals and the opposing needs that are required, whether it's automotive, whether it's public safety, whether it's retail, whether it's agriculture, whatever it is, they've all got different needs, and they're all going to run on the same physical network. Let's look at one which comes up a lot, which is automotive. I'm just kind of showing this just as a way of kind of showing the complexity of one such vertical, where you've got a lot of things going on. We've heard about kind of ultra reliable, low latency communications and the requirement for edge compute. Here we've got vehicle to people, you've got vehicle to infrastructure, you've got vehicle to network, you've got vehicle to vehicle connectivity. And even within that vertical itself, there's different requirements going on. So imagine kind of coupling this with the same network that's delivering, for example, like remote surgery, you know, and the type of network that's required, and also delivering massive IoT services. So really, this complexity in the set of verticals is really what's driving that need for automation. And this shows the kind of requirement through the life cycle, from the lab phase through to the field phase through to the kind of assurance optimization phase. Let's touch on kind of each of those. Automation in the lab, think about this in the kind of complexity of scenarios that you want to emulate in the lab prior to deployment. And really what you want is, you want your engineers focused on evolving the network, right, and developing content and developing applications. You don't want them spending time on having to kind of set up the framework for testing. And you can imagine the long test sequences that now go on, testing the various services across the verticals, try to optimize handovers and optimization techniques going on. And so really what we need is an automation framework that can easily adapt and can evolve to the test environment in the lab before you deploy. The more you can do here, the better and more robust network you're going to have in the future. And so if you then take that learning forward and go into the field, now what we're doing is we're turning up, we're certifying, we're bringing into service, and we're also providing maintenance and environment. It really requires automation of the test process where you de-risk the environment. Excuse me. And you also take complexity away from the technician who's doing the work. You can automate this, you can centralize it, you can bring the automated workflow to the cloud. So you basically take away the requirement for lots of kind of distributed elements, and you can cloudify that and centralize that, and then roll out services to each of the engineers. And this can have a significant effect on the time and the efficiency of rolling out for services. Because, you know, as we talked about with the verticals, the density of the network is so much more. And therefore, the time and energy and cost associated with bringing these cell sites into service, optimizing the cell sites is much greater. So what you find is that you can save significant amounts with automation in terms of like centralizing that, cloudifying the workflows and the instruments to bring these services into play. And then if we move on to assurance and optimization, this brings together the discussions that you just heard about the RAN intelligent controller. But in terms of automated analytics, I take us through kind of 4 phases. There's descriptive analytics, which really basically tells you kind of something's happened, and you can impute basically some missing data based on that. But descriptive doesn't tell you why it's happened. That then moves you on to diagnostic analytics, which gives you more about the core why. So you might have, for example, you know, poor service at a server site, like maybe there's congestion going on, but you don't know whether that's to do with the cell site itself. It might be to do with backhaul. It might be to do with a node that's going on. Maybe a link's gone down. So the diagnostic information tries to tell you kind of why and what's happened. Then predictive analytics tries to tell you about kind of what will happen. So now we start to look at And this is where kind of machine learning techniques come in, supervised and unsupervised techniques for machine learning, trying to predict what will happen and what if scenarios. So for example, you might want to create an optimal environment and a network configuration, but you want to predict what's going to happen before you apply that. So predictive analytics allows you to do that and get a high level of accuracy of what will happen if you roll this predictive analytics out. And then if we move on to prescriptive analytics, that takes into account the policies of the carrier itself and integrates those into the course of action. So for example, there might be some objectives that the carrier has got to apply in terms of maybe how much, I don't know, power changes or tilt changes or things that are going to go on based on 4G and 5G interactions to yield the right course of action. And this is why kind of dynamic learning's required, because if you look at just a very simple environment, which is where you kind of need machine learning attached to this, you know, you can have kind of simple thresholding that you're going to miss an awful lot. But again, the other thing is, as well as too few alarms, you don't want too many alarms. So the system has to be kind of always analyzing and adapting and looking at patterns so that any anomalies that happen can be brought out. You know, they may be one-off anomalies, or there may be a trending and a pattern. And of course, machine learning is there to kind of provide that, that analysis for patterns. So what you really need is this kind of virtual assurance function within the network. And this is where kind of I think the RAN intelligent controller will come into play here and be a kind of key part of this, where you're building models of performance. You're bringing machine learning techniques into that. You're doing anomaly detection. And also there's a kind of closed loop element of that, because that's also integrating back into the system so that the network can take the values that have been changed and integrate those through into any other kind of changes within the network that need to be applied. So this kind of closed loop, fully integrated system for classifying anomalies, looking at the evolution of that with machine learning techniques, and then integrate that into the optimization of the network. So really it shows that by bringing kind of automation into the three phases of lab, field, assurance, and optimization, you can reduce the risk associated with 5G and exactly really deliver on that promise of 5G to enable those disparate verticals we talked about at the start. All right, Ganesh, that was all. Thanks very much for listening.
That was brilliant. Thank you so much, Paul. Appreciate that.
No problem.
Now, moving on to the next speaker, let me introduce Bilal Khan from Lausanne, Switzerland, to present on the 5G smart tourism.
It's my turn already. So thank you very much, folks. And Paul, let me just switch on the video. That was a great presentation there. While you were speaking about these alarms, I actually, reminded me of a scene of this movie, where they're landing on the moon, and an alarm sort of goes off in the shuttle, and that guy is, what's alarm? I don't know. It's 21 or something, and the pilot is like, I have no idea, right? Yeah. and they just switch it off, right? So
they know something's happened, but they don't know why. Right?
They don't know why
Exactly.
That's happening. So I think it just took me back to that scene, and I was like, yeah, well, in those scenarios, effectively what you talk about is a seamless flow of events. I mean, where you're going through a lot but not realizing, and that's what I'm going to be touching in my presentation as well. But just allow me to share my screen, and we can be on the go. Okay, can you see it, folks? Yeah. All right, so yes, a little bit of an introduction, folks. Bilal Khan, like Ganesh said, I'm although I'm based in Lausanne, but right now I'm visiting Pakistan. So I'm joining right now from my home country. a little bit about what I do. So I work for this organization. We're a startup, more of a scale up. It's called Kiddo Dynamics. And what we do is that we run geospatial analytics using telecom data only. And when I say telecom data, I don't mean that we take data from any SDKs or anything. We essentially go to their telecom, to their core network, and we take things like CDRs, signaling, their CRM data. And then, of course, we develop solutions for the end industry, primarily, which are revolving around, the industries that we target are transportation, location intelligence, and then tourism, hence the topic. In my presentation, I am more focused really on the commercial aspects. What I will be talking about is what the world is going to be looking like once all the great presentations that you guys have given about why 5G is better and how it can enhance our capabilities. So I'm going to be talking about the end. So you will see a lot of fancy pictures in my presentation. There are not going to be any wires or arrows going from point A to point B. So yeah, to begin, yeah, there we go. So I think it's a great quote that I came across, and it's like, today's technology is tomorrow's tourism attraction, right? But in this case, it is going to be slightly different, and this is the sentence which I have added. It's like, and this time around, what's going to happen is that it is going to make it much more enhanced. We are going to have a much more immersive experience. And like Raj and like Paul, the way they've actually described the technology, what's going to happen is that it's going to be very, very seamless for the end customer, right? And we will be seeing this in the next couple of years, actually, as we see networks being rolled out. So estimated, clearly it's a big market, right? It's like a 11 billion market by 2025, and even post-COVID, right now, what people are predicting is, or analysts are saying, is that tourism is going to be growing at a CAGR of 3.9%. That is huge. And another interesting fact over here is that nearly 51% of this market share is actually in Europe. So, and that is where we see that 5G networks will perhaps be the first ones to really roll out at scale. But what are then the implications that this rollout is going to have on tourism? And I'm going to be talking about three areas here. First is tourism management. Here I'm essentially talking about all the authorities and the airports, basically, or hotels, the infrastructure of tourism, where safety and security right now, especially post-COVID, is something which is of paramount importance. The middle one, and perhaps the more important or the money driving one, is the experience. So how is the experience going to change? And we will be looking at use cases both in culture and in business. And then finally, without which I think no business will be able to survive or even exist in the next couple of years, is sustainability. Every business has to be very, very clear about what their impact is on the environment. And again, although you as experts would know the energy requirements, but then again, it's also more about how the benefits of 5G can be shared with the broader sort of society, and not just the cities in this case, right? So let's talk about the first one. So management. So yes, we have talked about this in the earlier presentations as well, but we know that approximately 1 million devices can be connected per square kilometer when you roll out 5G. Now that is huge, and because of COVID, I think we will soon start seeing. We have already started seeing in some airports, but then we will start seeing this at scale. Is the use of robots. Now, one obvious reason for this is COVID-19. Yes, because you are reducing human contact. That seems to be one of not seems to be, that is one of the reasons why the disease is spreading. And you will really see that these robots are going to start springing up in places like airports, hotels, and shopping malls, right? So much so that right now, the hospitality robot industry is going to be a $670 million industry by 2030, and it is growing at 27%. the CAGR is 27%. That is huge. And then this second image that you see over here, this is something that I've taken from our platform, and what you see is the state of Qatar. And we are kind of managing or monitoring the crowd, the crowd of how they are moving. And this is of a particular area. So what we are showing in this image is where the crowd is mostly concentrated in this case, right? And where they are coming from. But the interesting thing about this picture is that this is 1 day old. So, and I think with 5G, essentially what is going to happen is that this picture, which right now is 1 day old, this is going to be literally real time for us, right? And why do authorities need this? They would need this for crisis preparation. See, it is very, very clear now. It is not a question of if, it is a question of when, right? So resource planning, distribution across any tourist location will be of paramount importance. We see all the threats that are emanating in different tourist destinations. And real-time crowd management and control is something which is going to be of paramount importance. What's interesting is that the crowd will not know that this is happening, but the authorities will. And that is one major change we are going to see there. So despite, increasingly, although we will be removing ourselves from the process, right? Our capacity to actually respond to the crisis would improve in leaps and bounds only because of this technology. The second thing is about experience, right? And here's something really interesting. What we are going to see is that an experience is essentially about storytelling. So you tell a story about a particular place, for example, the Colosseum. Let's take that example. So you will tell what used to happen, the gladiators would come, enter through here. And that is where I believe, and what we are going to see in the future is that there's going to be a merger between the creative studios and tourism industry. So we'll expect Steven Spielberg or Christopher Nolan to be directing videos around a tourist space where it won't be odd that you visit the Colosseum, and Christopher Nolan has actually created that whole experience, right? And so, but what are the technologies which are going to carry this? So it is going to be the augmented reality and virtual reality. Right now, yes, if anybody of you has been going to the Mobile World Congress, you would probably know that up until about 2-3 years back, every company was advertising their AR and VR technologies. But naturally, we would see some bugs there. It wasn't that smooth. That all is about to change, because cultural tourism right now is about 29% of the total. So about 29% of the total consumers basically go to a place because of their culture, because of its culture. And it's because of these technologies that they will have a much more immersive and a much more enhanced experience, right? They will actually be able to see that happen. And then the second point is about the seamless integration. And we talk here about the business travelers, which is a huge industry. Again, it's like 44.2 billion by the end of 2019, given that because of COVID-19, we are going to see some decline there, but still it is going to continue to grow. And here is an interesting thing I read about experience a while back, and somebody asked a question like, what is a good door? And the answer from an experience point of view is, a good door is a door whereby once you pass through it, you do not realize that you actually went through a door, right? And that is what's essentially going to happen to all the hotels which suddenly upgrade themselves from Wi-Fi or broadband to 5G. All the devices or the ecosystem of that hotel is going to be seamlessly connected through the network, where you will be going from one place to the other without even realizing that, and you will find it really perfect without even realizing that there's technology back at work, which is making your experience much more lively. We would know that there is technology there, but it will still look like magic. And you should check out this company, Ardemont Studios. I mean, they're doing some great work, specifically around the Roman baths, which is in England. I mean, they've actually created some very good VR experiences in the Roman baths. And if you get time, do check out their websites. And then finally, we come to the sustainability. Now, by and large, we know that 5G is going to create a more equitable society, right? And why? Because it is going to democratize the opportunity. And specifically, what it is going to do is push it more towards the rural side, right? But the first point I want to talk about here is it is simply more energy efficient. Now, yes, I do understand that there is an argument that, yeah, since the number of machines are going to increase, or the IoT devices, we are going to be, in the end, perhaps spending more. But it is a very powerful comparison. Like about 300 movies on a 4G, if it requires 1 kilowatt hours, you can do the same. You can do about 5,000 movies on 5G, right? With the same energy. So clearly we do have that energy advantage there, right? Given the fact that the carbon footprint of ICT industry is basically equivalent to airlines. But of course, in the total equation, we may end up spending more, and that is what brings me to the second point, and that is the democratization. And what we will see is that, the smaller towns which are around the big cities, they are going to start getting visible. And once those towns start getting visible, it is automatically going to create less and less pressure on these big cities, right? So, and effectively, once that happens, your energy requirement, your overcrowdedness, your urbanizing, and there is this sudden need to urbanize reduces, because right now, even in a smaller town, you can get the facilities, or you have the same opportunities like you would have for being in a big city. So in the total equation, I would think that because of 5G, it's lower consumption per device at least. And then the fact that, it is going to uplift all the rest of the environment and even make smarter cities. We are going to see that there's going to be a massive revolution there, or at least the sustainability element is going to be much more pronounced when we are talking about 5G. Going forward, growth will, it's very clear that growth is only going to be sustainable if we can leave the environment better than we found. If that's what we are up to, yes, we have a business case. Specifically, read through the sustainability development goals of the UN 10 and 12. I mean, these are goals where 5G can directly contribute. I will leave you with the final quote, and this is by Stuart Brand, which says, "Once a new technology rolls over you, if you're not part of the steam roller, you're part of the road." So it's really up to us whether we want to be the steam roller or we want to be the road. And I would much rather be the steam roller here. Thank you very much.
I love the last quote. Thank you so much, Bilal Khan. I appreciate that. Now moving on to the next speaker, let me introduce Sadiq Malik from Paris, France, to present on role of software app in 5G world, ISV engaging telcos. I believe that's independent single vendors, if I'm not mistaken.
Oh, yeah.
Yeah.
Can you see my screen?
No.
Sorry.
Sadiq, I think, yeah, I think
I can see you.
Yeah.
How do I share my screen?
Just 1 second. I think I have given you the access, right? The co-host. So you should be able to share your slides.
Okay, let me just do that. Does it come?
Yes.
All right. Thank you. Let me put full screen.
Yes.
All right. Thank you. My presentation is more about the impact of 5G on the software industry. And this is something that I think a lot of people have not realized, that actually 5G is going to change the way we consume software. Now, this is a concern among the big telco operators as well. And Verizon on the left there were offering $1 million in 2019 to anybody who could come up with a killer app for 5G, right? And what has happened is almost all operators, including Deutsche Telekom, EE, all over the world, have got research centers that are looking at 5G application development. So they've set up little studios where they invite software developers to come and develop their software and test it in a sandbox environment. So this is the big thing in 5G. Now, why is that? Well, 5G basically, and I'm sure you know better than I do, because judging from the presentations, is actually a cloudified softwareized network, right? The telco network is going into the cloud. This is from Deutsche Telekom Senior Vice President. This implies revolutionizing and future-proofing infrastructure so that it agilely delivers intelligent services in real time to customers. Having these features will be the Turing test for service nativeness. And that's the 8 trends on the left side that Deutsche Telekom is using to become, or what they say DT is becoming, a software telco, which means edge computing, control user plane separation, SD-WAN, and stuff like that. And of course, Open RAN is also part of this game. The next one that has come up is the rise of open source. Now, for some strange reason, open source solutions, Open RAN, and the word open has suddenly become a la mode. And Open RAN, or the rise of open source, is become extremely active now. And of course, the leader there is something called OpenStack. And of course, Amazon has got into the space. And you've got all sorts of software languages that are all open source, mainly from the Apache Foundation, that mobile operators are saying that let's have a microservices architecture now. The RAN is also going into the cloud, and we need to do something about the applications, because the winner in the 5G game is not the one with the best network, it seems, from the RAN side. It's the guys with the best application and customer experience. And this is where the issue of rise of open source has come in. So cloud, open source has come in. And this, of course, is going to affect the software development industries, ISVs. Now, telco 5G imperatives, reimagining the customer experience. I've talked about that. If I were to take only one on this side here, companies need to transform themselves into software companies and must be able to leverage cloud-native software development, which means they need to create what we call an ecosystem of partner ISVs. That is the telco imperative. And that's why the search for the Holy Grail has started. That's why those development centers are being set up by the big telcos and inviting software developers, come, please develop your software applications in our laboratory and test it out. And we'll give you free office space, we'll give you free tools. And if you do come up with a killer app, then of course we'll share in the the profits. So these are the modern telco imperatives, which now comes us to the issue of what do we do about ISVs. Now, if you were to look on the left side, successful cloud native software company, you need to look at the developer productivity, developer retention, and developer fulfillment. This is specifically focused on how to attract and retain developers and how to get them to produce software that is going to change the world. Now, you know and I know that software developers is a completely different kind of animal, okay? These guys are young, mostly millennials, and their mind works in a certain way, okay? They're not corporate animals or corporate, what shall I say, slaves. And you need to handle them correctly in order for them to come with something important. Now, in this world, there is something called Scrum and CI/CD, continuous integration, continuous deployment. And all these new software development technologies that have come up, and in a microservices architecture, which were developed and mastered by companies like Netflix and Amazon and others. Now, those are geeks, right? Anyway, they know how to work together. They know how to come up with the kind of services and cool applications. So they know how to nurture software development talent, which the big telcos find it a little difficult, although they are, of course, trying to do it. So this is basically a way of looking at the developer or the ISVs. Developers with cloud native DevOps skills command high salaries. These are the kind of salaries that you're looking at. Almost everywhere, the salaries for site reliability engineer, Golang developer, senior software engineer, even Scrum masters, almost everybody is earning about $100,000 and plus, because cloud native development is the key to producing high quality software. You are using a different kind of software development technology, which is called Agile and DevOps. We're not using waterfall anymore. You're dealing with a different kind of people who are to be nurtured, paid, motivated in order to develop software. Software is the question that sometimes asks, what is the 5G killer app? And that's something I've been thinking about quite a long time. What is the killer app? And more, I've come to the conclusion that the killer app is the software app that is going to be developed. Now, what that is, we don't know yet, because everybody in all the laboratories are busy developing these things. So software is the killer app of the 5G world. And if software is the killer app, then the 5G standalone core is the emperor of 5G and not the RAN. Okay. What is suggested here is that one needs to look at, and all companies have this, these things are available on the internet and software development platforms are there. I've been using Amazon myself. It works beautifully. Those of you who've used Azure or Google, I'm sure you will say good things about that. But let's go to the bottom. Does the platform make developers feel empowered, enthusiastic, productive, and safe? What is the developer retention rate? What evidence is there that the platform facilitates and supports cultural change? Now, you know that the companies like Amazon, Google, and Microsoft Azure are ramping up their training curriculum in order to get more people certified. Of course, Amazon is the most active because their training is just absolutely, it's like a tsunami. If ever you register for them, I think you will spend the next 200 years just learning Amazon, okay? They call it the democratization of software. So the choice of development platform depends definitely on the kind of software engineers you have. Now, if the software engineers you have are all certified on Amazon or Azure, and I would tell you that they're all the same, right? Except Amazon is a little more expensive. It's broader. They have more services. There are over 200 services. The question is, how do you structure teams that some are certified on Amazon, others are certified on Google, and the others are certified on Azure. And I have seen software developers who are certified on all three, because of course, software developers have realized cloud software development and open source is the key to money. And telco operators are looking for them in order to develop applications and content that will monetize the 5G network. Just to look at the kind of applications we're looking at, I'll just touch on one here. The one killer app that is being talked about, should I call it killer app or killer content, is the issue of cloud gaming. Cloud gaming is supposed to be big. I mean, there are many things. I'm just touching something on the consumer space, and cloud gaming platforms are really coming up rapidly. And the telco operators are making deals, Verizon, Vodafone, with the cloud gaming companies in order to offer that. You know, and I know that with cloud gaming, on 5G, that's the big user thing, because you don't need a full device. You can do the cloud gaming with the low latency, high capacity of a 5G network on your smartphone. And smartphones are getting more powerful and more powerful. This is another one. Niantic is a company that you should keep in mind. Niantic is focused on delivering augmented reality experiences through gaming, okay? And gaming company Hatch said the operators need to step up if they wanted to take advantage of the cloud gaming market. And of course, the technology companies, operators, content service providers in this thing. Niantic is quite interesting. They have a game called Pokemon. I don't know whether you've played it, but Pokemon plays very well on a 5G network. Again, this is content, a whole new group of people coming into the 5G space. This one you can read when I send you a copy of my slides anyway. Just look at the figures on cloud gaming. It is just absolutely exploding. Mobile operators have realized this, and they are making different efforts in order to get in. And wherever there is money to be made, you can be sure that the OTT players and the hyperscalers are in it. Did you know that the App Store generated $15 billion in revenue for Apple from third-party developers in 2019? That AWS generated $3.5 billion in operating income, contributing to 56% of the entire income. In 2020, 85% of smartphones run Android. Openness drives innovation, revenue, and profit. Apple found success with App Store by opening up its iOS APIs to third parties, creating an open ecosystem. And of course, when I talk about open ecosystem, I'm also talking about the open API revolution as well. That's a separate large subject of itself, right? You know how that works. Uber was able to build a market-disrupting application by leveraging open APIs to incorporate services like Google Maps and more functionality. as 5G paves the way for Internet of Things, edge application, vast landscape of opportunity. But this opportunity is only when you open the telco operator core network with open APIs, you invite software developers to start developing applications that use a mix and match, mashing up, it's called mashing up applications and content. And that might be the key to monetizing 5G, especially in the consumer market. Different thoughts come in with that. Okay, I think that's it. So overall, just final words is, for any country now, 5G, they say, of course, does 5G have an effect on the GDP? There are several studies that have been done by reputable companies that show that 5G does affect GDP. And 5G will affect agriculture, smart this, smart that, smart the other. But the thing for me, where 5G is going to create a real revolution, is in the software development industry in a country. Because if 5G comes in, and with the right regulatory government levers, governments can create software development centers and get young people working, developing software for 5G, that in the end is going to create greater growth in GDP and greater growth in employment than simply the basic communication services. That's why I believe that the independent software vendors, the software development industry, actually in a couple of decades is going to be the biggest beneficiary of 5G. Those are the winners, the content, the gaming and stuff like that. And it's good for the country. People get jobs. Young people can learn cloud computing. Young people are good at developing software. Software development kits with open source are available. You can just download it and you can create an application on the fly these days. So that's it.
Thank you. Appreciate that. It was an excellent presentation. Appreciate it. Now, moving on to the last speaker, I would like to introduce Muhammad Radwan from Sydney, Australia, to present on 5G, AI, and machine learning in vertical industries.
Yeah, thanks, Kanish. Can you see my screen?
Yes.
Let me share. Okay, so hi everyone, and thanks for the opportunity, Kanish. I'm glad to be part again of this great discussion and with this brilliant bunch of people. So today I'll be talking about 5G and AI in emerging industries. I'm Muhammad Radwan. I'm the CTO of L2X Technology. We are a system integrator specialized in providing solution and system integration for telco and utilities companies. So the agenda, I'll give a bit of overview about AI and Industry 4.0, how AI and machine learning can work with 5G hands in hand to provide better experience to some of the industries, and we'll end up with some of the use cases. So let's begin without further ado. So at the start, I'll just give a quick definition about these terms because it's used a lot. So what is artificial intelligence? I will use a simple definition. It's an intent to teach the machine to act as human. And to be more specific, currently we are trying to teach the machine with data, with modeling, to act as close as possible to humans. This doesn't only include just giving the machine some set of instruction and expecting the machine to go through this instruction and implement them in a fast pace. This is not what we are looking for. We need the machine to have also reasoning. So they will be able to do something based on something. They need to have perception. If the machine will be able to have some sensors to sense, able to see object, able to measure some environmental pattern and so on. Data-driven, just in a couple of seconds, artificial intelligence is not new. We have a couple of waves. Even it started in the late 90s. We have like the first wave with symbolic AI, and then we have a second wave about expert systems. Some people believe we are now in the third wave, which started early 2000. How to use artificial intelligence based on data-driven. We know now that data is the new gold, and how to use this data to come with more intelligent decision and reasoning for the machines. Last but not least, I'll talk about like a subset of the machine learning, which is deep learning. And I give you an example about reinforcement learning. So we talk about supervised learning, unsupervised learning, expert system. These things that include some direction to the machine. And reinforcement learning is like how learning by trial and error. So you just identify to the machine what is the state, what is the thing that you need to achieve, and you give us a reward. So an example, she knows that if I finish this, I will get high 10 points. And then the machine by itself try to learn new ideas and come with new plans to give better rewards. As example, as you know, in 2017, AlphaGo, which is a deep learning application, was able to beat human in a Go game, which is different than chess because it's not predictable as chess. Secondly, let's take this to go to the telecommunication field. These are, I took this from ITU requirement document, Y3172, talking about like their perspective, how the machine learning architecture should look like. I will not go through these different elements of the module. I just want to highlight that the idea is you need to identify your intent as machine learning intent, and then you have a very important component with the machine learning framework orchestrator or function orchestrator. These are the one which manage the whole machine learning model and pipeline. And as per the application, you can decide if I need a one machine learning pipeline or I need a second one. I use it as a sandbox to do the training and the testing and development on this one. This is the one on top. And then you have the pipeline, you know, the different component, the source, which could be the user equipment, and then how to collect the data, how to do some pre-producer to make sure that this data is ready for the machine learning modeling, doing some cleaning, doing some formatting for this data, and then doing the policy, and finally push this output of the machine learning to the sink, which may be one of the OSS application or other application on the telco, which will benefit from this machine learning. Last but not least, if I talk about Industry 4.0, I believe there is multiple pillars for this Industry 4.0. I'll go quick because I know we are actually part of it on time. These pillars, I'll talk about automation. So let's say we have a new factory, and this factory, he wants to get benefits of all this new Industry 4.0. He needs to consider automation, like doing process automation, how to improve the management, how to minimize the OpEx. Connectivity, this is something critical. You know, now the majority of factories and industry using wired. So how to start to utilize more 5G, 4G, LoRa, and Wi-Fi 6, more wireless. IoT with the thousands of sensor and actuator, which can help them to provide a better job and improve their profit rate and ROI. And then all this data coming from all these sensors, from all these machines, we need to gather it in a way, put it in a data lake or data warehouse, and then start applying the machine learning and analysis on these things to be doing some prediction for the future, provide some insight. What is the best way to operate this machine? Shall I do like additional power, additional input, and so on? To get to this decision, you need some cloud computing. This could be on the far edge, near edge. It could be like centralized, as Sadiq just mentioned, like in Azure, AWS, or Google, or whatever as you like to have. And finally, the magic piece or the glue for all this component is to provide system integration to integrate all these above components to achieve the final goals. Just to give you like a hint, as I just talked about, like most of the current factories, as I mentioned, is using wire, but now the percentage increased, like 56% now, mostly using, 54 using like a kind of wireless between 4G, 5G, and Wi-Fi. And by providing 5G, we can achieve many things. We can provide better CapEx and OpEx for this factory because you don't need to worry about cabling, troubleshooting this cable. You have a very solid connectivity, wireless, and it could be secure. So as a factory, you can have multiple options. I can build my own private 5G slice, or I can use one of the public 5G offered by one of the CSP on the region. Just as you can see, just a sample of like what we have in Nokia. Announced in February 2020 that they developed more than 130 industrial enterprise using private network. Also, as you can see, hyper 5G, as I mentioned, is available. And Japan have like a great initiative. They call it Society 5.0. They want to provide AI over high-speed wireless. This will be like implemented with 5G and also till the year 2030 with 6G as well. So getting back to the industry and some of the benefit, as I mentioned, like, and as also like a couple of my colleagues here mentioned before, now the amount of possibility is huge. Paul, he mentioned we have 10 to the power of 200. So to build a program which can detect and provide a specific action for each of these possibilities, this will be insane. So now we need to train the application to understand this different possibility, and the application by itself will be able to decide what is the best way to achieve this strict SLA. So this will be critical for something like robotic surgery, as example, where is killer, time is killer. And also we can do some, like, let's say if we have like a telco, we need to provide thousands of different slices to the different user. Can do this with AI. So just to sum it up, I will not go through all the points. We can work like it can help in productive line flexibility, automated guided vehicle. As you can see, it can help with connected co-worker, as my colleague mentioned, with AI, augmented reality, virtual reality. You can from centralized places can guide these technician and guide this engineer what is the best way to fix a machine or make it work in a better way. I will end up with two use cases. The first use case, actually, this is a source. It's a university in Denmark, Aalborg, and I hope I'm pronouncing the name correctly, Aalborg. So this university, in cooperation with Nokia, they developed, as you can see, this lab for the futuristic industry. As you can see, they provide multiple connectivity with Wi-Fi 5, Wi-Fi 6, and they provide some private connectivity with 5G and 4G, and also they also provide a slice using public internet. So providing this architecture can give a better connectivity for this factory and make it achieve its goal. There's still, for sure, there will be some challenging how to collect the data from all these different resources and how to take this data, put it in a structured and unstructured way, how to model it, how to make it ready to consume by the upper layers. Another point is how to secure this data that you are collected, how to secure it during transit and at rest. And like we have a lot of things like TLS, like this encryption model, which the time doesn't allow me to talk further about it. My last slide, I will finish with this one. Also, we can utilize some of the hyperscaler, like we can use an example here is AWS. So let's say we have a factory. So this factory can utilize multiple layers of services available in AWS. He can go to AWS and say, I just want the infrastructure. I have my own modeling. I have my own analytics. I have my own application. I just need the infrastructure. So please provide me with an application like TensorFlow or PyTorch. And then the factory and the developer at the factory can develop the other layers. Or in another case, you can take the full service from something like AWS with their application, which provide this data modeling like SageMaker, and they provide additional AI services ready to use, like voice recognition, face recognition, and even they have a dedicated service for factories. They call it AWS Panorama. It's combined with CCTV camera. As I mentioned, with AI, you can detect some different like face recognition, you can put it on the exit and detect like if there is like a truck getting out in the right place, right time or not. You can also detect some anomaly, sorry, in the temperature or the humidity or whatever. So it's brilliant. Actually, there is no limit. The sky is the limit of our imagination or what we can do with combining these brilliant technologies together: AI, IoT, 5G, and for sure automation and machine learning. Thank you so much, and back to you, Dr. Kanish.
That was a brilliant presentation. Thank you, Mohammad Radwan. I appreciate that. That was really excellent. So let's have a quick 10 minutes Q&A session. If anyone has some questions, please do ask among the speakers. Maybe I can start first. I have this one interesting question based on one of the presenter. Yeah, Dr. Masin, you were mentioning about the question of either X app stores or X apps as part of RICs, right? So that is quite interesting. Even this is something was very new. I didn't even know that the X apps can be available from the RICs. My question is okay, let's zoom in terms of the 5G killer app. One of the things that is really visible for me is metaverse applications. I think one example that I can take a cross reference was from South Korea Telecom, because South Korea Telecom with their partner Jump Studio most recently came out with one fantastic studio music video with the famous South Korean ex-BTS and plus UK Coldplay band. And they just launched this particular music video, which kicked like about within a day for about almost 20 million viewers, right? This is amazing because the content was used with the metaverse, with a combination of NFT and properties and all that sort of stuff. And but that was one kind of development from the studio. In parallel, Jump Studio also are preparing a store, app store, that is available in the Google App Store as well, where they develop all kind of interesting metaverse applications as well. So that is a trend where I think hyperscale players are playing a much more important role into getting all the killer apps to be in their platform. So my question is to anyone over here, do you think that X apps will able to kick much more better in as part of the RICs in comparatively to the hyperscale players?
Well, I might start, and I think that there are different aspects to it, but basically when you are speaking at the different so the different players at the different bodies, they have different approaches, but one thing is really interesting that, for example, we are part of ONF and developing X apps, and one of that is traffic steering. And when we started to talk to them about presenting that, they said that we are the first company to present something like that. And maybe they should start thinking about having that platform based on which you could have that apps available for the operators. Also, when speaking to some commercial companies, they are also thinking of having such an approach where having certain RICs, you could have the X apps to be verified. The important point is that for having such, let's say, conversation platform, you need scenarios that the operators are actually interested in, not just the regular scenarios and just hexagonal grids. I think that this is where we should be developing this. And then on the other end, there are companies who provide the RICs together with some X apps, and they also maybe would like to just get on board some companies that are developing X apps to have a full portfolio. So there are like two sides, and the hyperscalers you mentioned, and when they are getting towards the Open RAN area and having, I don't know, rigs on Google Cloud and maybe at the edge, but still on the cloud platform, this is where that actually could take place. The important point is that this is totally different than the regular XApp, where you have a individual who has his smartphone and could download it and check. That's a live network. You need to perform, you need to add the SLA that need to be fulfilled and things like that. So I think there are much more requirements when speaking about XApp store compared to a regular app store for the smartphone. So in that, I think both ways could be done. I think there will be tries to do both sides. I think there will be XApps that will try to get in on the different parts of the world. Maybe that will merge into a single big store for those, but I think it's much more challenging and requires to get more people on board to build up the whole ecosystem of the operators and vendors and platform providers and ecosystem for the simulation, so that they really reflect what the operators want to have.
Awesome. Thank you, Doctor.
Yeah.
Anyone else have anything to add on, or?
If I may comment, Kanish, like I'm not like this is like we cannot predict the future, don't have a glass ball, but I'm not sure. I need also your opinion. Maybe the hyperscaler with the CSP, maybe they will cooperate. Something came to my mind, like how Verizon and AWS and how AT&T and Microsoft, especially let's focus on AWS and Verizon, how they build the edge. And now any user or any software developer can go to AWS and choose to apply his application on one of the edge location on Verizon. So will this apply to RIC? Something else like this area radio is not my specialty, but I'm not sure how open or how simple it is to write an X app for a RIC. I believe like the number of software companies and the number of users is limited. So will it actually be similar to the as you mentioned, Dr. Marcin, will it be similar to the normal app store as example, or it will be some sort of specialized application only written for the operator?
Yeah, that will be for sure only specialized for the operators.
Yeah.
The only similarity will be that instead of having that embedded in the software for a base station,
Yes.
is that you have a platform where you can compare different applications for the operator, so that he can judge based on the performance which of them is better, and then that's one thing. And then if they are not, I don't know, if they are not satisfied, they could just download another one. I'm not saying that this will be similar to the way the actual app store is working. It's more of the concept where you could put different applications from different vendors for this actual specialized ones, and that it will be a specialized applications for sure.
Right. The other interesting question that I would like to address to Dr. Peter Raj, also to anyone on board as well, in terms of the age boxes. I think, as you are aware, the hyperscalers are getting the momentum in eating up the telco vendors market by having a partnership with the service providers or the mobile network operators by introducing the cloud edge services by placing the boxes closest to the mobile network operators customers as well. So my question is that in terms of the experience of Dr. Peter in Reliance Jio, how that has been deployed in terms of what are the boxes? Is it very dependent to the hyperscale players or the vendor players?
Yeah, two things. So pure play edge device clouds are being set up in each and every location, in each and every offices. Similarly, as you know, telecom tower places can be leveraged for edge computing cloud formation. That's one thing. But there are other aspects. When we say edge cloud, cloud will not be not only formed out of server machines, but also edge devices. That's what I talked. But I think Jio has tied up with Microsoft Azure Cloud to have 1,000 edge clouds across India. So that is being borne out by Jio. Software infrastructure is being given by Microsoft. So that's a typical traditional cloud center, but the number of cloud servers will be in the lesser side. But as I told you, that is one aspect that is going on now. But now with the maturity of edge cloud formation and other kinds of resiliency mechanism like Istio, API gateways. So in future, we can definitely anticipate such kind of edge device cloud centers in specific locations like manufacturing floor, maybe homes, hotels, kind of environments. But otherwise, as per the trend says, the edge cloud will be formed out of a smaller number of server machines. So in typically there are several edge appliance providers like Dell is providing such kind of edge appliances. This GE has a very interesting edge device platform that helps to develop edge application using edge by running on that platform on edge devices. So in different layers and tiers, so many new processes are getting initiated. In due course of time, in the days to come, we will come to know more clarity in which direction that edge device cloud will travel. That is what my understanding.
So is there a Google Cloud or Microsoft Azure or any other hyperscalers that have partnership with the mobile network operators generally in India?
Yeah, Microsoft Azure is tied up with Jio. Jio is the, as I told you, hardware provider. Software provider is Microsoft. They are planning to have 1,000 edge clouds across India. Right. In maybe in Bangalore, 3 or 4, is similarly other cities. So that is already planned, and that action got started already. But typically for certain use cases, scenarios, I still recommend device clouds, edge device clouds, rather than a cloud being formed out of server machines.
Awesome. So I think we are coming to the end. And thank you so much for all of your participation. I really appreciate it. And this particular program will be uploaded on YouTube in a couple of hours of time. And please don't forget to click subscribe button on our YouTube channel, Global 5G Evolution. Thank you so much, everyone. Thank you. Have a nice day. Thank you.
Thank you.